The same thing happens if the inside is a parabola.
Last question, there's a question
10A and B. So in blue, I'm going to graph this first. And this is good for us because it makes us review chapter 4 and chapter 5. On that graph, can you tell me where the vertex is?
negative 2, 2.
Negative 2, 2. So I go negative 2, comma 2. And will it open up or will it open down? It'll open down. And since the A value is 2, we could go over 1, down 2. Over 1, down 2. That's going to be important because we're going to want to make sure that we label our x-intercepts. And then it would go over, down how many? 6. And of course, you could also plug in 0 for x. 0 plus 2 would be 2. 2 squared is 4. 4 times negative 2 is negative 8. Plus 2, negative 6 for your y-intercept that way as well. Then right beside this, in green, I'm going to graph the absolute value of what we graphed in the first one. So you already figured out in the first one, when you plug in negative 2, you get 2. And the only thing we're adding is the absolute values. So on the second graph, everywhere where your y values are positive, they're going to stay the same. So negative 2, comma 2 will still be there. And these critical points of negative 1, comma 0 and negative 3, comma 0 will still be there. But what's going to happen to 0, negative 6? It's going to flip up, and it's going to be up at 3, 4, 5, 6. 0, comma, positive 6. This part of the parabola is exactly the same as it was before. But all the places where the y values are negative, they are going to get reflected up over the x-axis. And this is the graph of our new equation. What is the domain and range here? The domain is still everything, but the range is bigger than or equal to 0. So for graphing absolute value functions, you can do it with lines and with parabolas, because those are things you already know how to graph. Grade 12s, literally yesterday, did this exact same thing, but they have learned how to graph lines, parabolas, cubics, logarithmics, sinusoidals, a whole bunch of things. And they have to do the absolute value of all of them. But it's the same idea. Whatever is below the x-axis just gets reflected up and over because you're making all of those y values that were negative into positive ones.
So is it like better to always sketch
The original one first?
Original one first?
Yes. Because if you see the original one, what's going to be super important? These critical points are super important because that's where, those are the last points that stay the same, and your graph is going to change directions there. So let's look at the second one. Again, first, in blue, I'm going to graph the inside, which is negative 3x squared minus 1. What is the vertex of negative 3x squared minus 1? Is it in standard form? Do we have to complete the square? It is ready to go. Okay? Sometimes it's hard when there's just an x squared to realize that your vertex is at 0. Zero and negative 1. Which way does this one open? Up or down? It opens down. We would go over 1, down 3. So I would be at 1 comma negative 4, over 1, down 3, negative 1, negative 4. Next time it would go over 1, down 9. Do you see that all of your y values are negative? So when I go to graph the absolute value of negative 3x squared minus 1, this whole thing is going to get flipped up 0, negative 1. Is now going to be at 0 comma positive 1. 1, negative 4 will now be at 1, positive 4. And if this whole parabola got flipped up, this is the graph of the absolute value. So the idea of absolute values, both with lines and with parabolas, is that if you can draw the inside first, then wherever the inside y values were negative to begin with, in other words, wherever the graph was below the x-axis, that part gets flipped up and over the x-axis. In this case, the whole graph got flipped up and over. In part A, only part of the graph got flipped up and over. Okay, now you can circle 5B, 7B, 10C and D, and also 15.
Wait, how do you graph just one number?
How do you graph just one number? What do you mean by graphing like a single point?
It says sketch a graph of each absolute value function. Y equals 6.
Oh, that's, so y equals 6. You're looking at the homework. How do you graph a single number?
Put it on the thing.
Y equals 6 is a horizontal line. Right? And the reason for that, like, I'm going to, oh, there we go. I'm going to plot some random point, okay, on that graph. And I ask you, on y equals 6, if x is 7, what's y? And you're like, well, y is equal to 6. Good! If x is 3, that's y. Well, y is still 6. Y is always 6. It doesn't matter what x is, and that makes a horizontal line. In the same way, x equals graphs are always vertical lines.